Hi guys, welcome to Learning Electronics Repair. Have a repair job in, and we've seen these before several times. This is from a different customer. There must be a lot of these on the island. All these things were just extremely popular products and they're kind of ubiquitous. Yeah. So Dynacord Powermate 1000. We've certainly seen the Powermate 1200s, and I think maybe a 600 for that matter, so variations on this. This one, well, the sliders don't feel in bad condition. At least not as bad as some of the other ones I've had. Yeah, okay. The owner brought it in yesterday. So yesterday was Monday, and he says, I need it back for Friday, whether you fixed it or not. So the fault on this is that one channel is working. So he can use it as a single channel. He's a live artist of some sort or other. So if I can't fix it now, maybe at least I can figure out what's wrong with it. Might have to order some parts. Okay. Yeah, I know the story of my life and this channel, but I said he wants it back on Friday. So it all needs to be back in one piece again. Okay. As he says, this is working on one channel and not on the other. I'm not going to worry about this thing going bang. I'm going to plug it in and let's see if we can just confirm what he says. Actually, this guy must be a guitarist because he's the one who brought in the Boss Katana guitar amplifier some months ago. The one I could not fix. Basically, it powered up, but didn't really do anything. Kind of like doesn't complete the boot sequence, even though the microcontroller is reading the BIOS ROM, and even though I got the latest firmware into the BIOS ROM. Okay, so couldn't isolate the fault on that. At the same time, Detlef actually bought one at the car boot sale, and he was going to let me use that one to swap some parts from his main board to the other main board to see where the fault was. But then he unfortunately, or possibly wisely, sold it before I had the chance to do that. Okay. So yeah, that must be what this guy does. And actually, in the past, I fixed some HK audio amplifier for him as well. So, a bit of a regular customer. I've noticed actually there's a sticky thing on here, so this channel must not work, I'm guessing. Yeah, do not use for some reason. But he has not asked me to fix that, so I'm not going to look at that. Right. So, he says only one channel's working. I think he might have mentioned the other channel was in protect mode, but there's only one protect light, so we see. Let's just power this up, take him at his word. Okay. That it won't do anything violent. What happens? Well, the fans come on and then it goes protect off, power on, and the fan goes off. I know the fans on this are controlled, so obviously the microcontroller or whatever's in here that's handling all the monitoring. And I don't think it is a microcontroller. I seem to remember this is all done with op amps, yeah, and gaffer tape. Okay, so it's coming out of protect. Right, so I'll connect my speakers. Let's feed some audio in and let's see if he is correct. Okay, and this has an interesting fault. So that's the left channel, and that's the right channel. Okay, so it's not that the channel doesn't work, it just sounds awful. Don't you comment about the Northern Soul sounding awful either, otherwise you're not my friend anymore, yeah? Okay, that is interesting. I'll just try another channel. First question. Have I, technical term, knackered my speaker, one of them, with something else I've been trying to repair? Well, I'll just swap them over. Okay, back on. So that channel sounds okay. The other speaker, yeah. So this channel still sounds the same on the other speaker. And this one sounds awful. Okay. Next question. Is the fault on the mixer panel or on the amplifier board? So actually I've fixed enough of these now to know I can test this very easily. So here we have some jack sockets to say power amp inputs. So they feed directly into the amplifier. I have the schematics, by the way, and you guys probably know that because we fixed these sort of things before. So this definitely goes directly into the power amp. Okay, so if I feed the audio in here, these controls will do nothing, so I have to control this with my mixer. So I'm going to switch it on. The mixer's turned all the way down. Power it up, and then the mixer. Now I have the same problem, so this speaker is working and that one sounds awful. So 100% we have an amplifier where it's badly distorting the audio. Okay, so let's get this thing apart. Okay, so I've definitely worked on this one before because that's me. Okay, and here we see the amplifier board. So quite a bit of dust and cobwebs and things in this one, but compared to a lot I see, this is not bad actually. Okay. So, from working on these things before, across the front here on the heatsink, we have some voltage regulators, I seem to remember. I think these generate the plus and minus 15 and 12 or 24 volts or something on that one, I think. There's 4 devices actually, okay. We have 2 fuses here, so I would think probably this is just the plus and minus 24. So because the problem's just on one amplifier, I don't really see that this would be an issue. Let's see. Yeah, that one's okay. This also looks okay. Yeah, that's also okay. Then we have, you can see under here, a red and a blue, and this one I'm pretty sure that's a ground lead that goes to the mixer in actual fact, that one. The red and the blue come from this bridge rectifier, so this has 2 yellow and a black. So the black one, which yeah, that disappears down there, that's the ground. Okay, so problems on one amplifier. I don't see this being a fault with the power supplies at all. Let's get the schematic for this one. I'm pretty sure we have it. And also I'll just mention that all the output transistors are all under here, under this metal casing, so we need to get the fans and that off to get to those. Okay, could be just a thought here, if we had short circuit output devices on one channel of the amplifier, but on one side just the plus or the minus on that amplifier, and we have open circuit emitter resistors, that might be a possibility. But I guess, you know, this is what we're here to find out. Yeah, and there's lots of other possibilities. But having thought of that, I think I can immediately say that's wrong, because protection would come on. There's no protection, and one of the protection circuits, I'm pretty sure, monitors the voltage for an offset to the speaker. Well, I guess we will see. Okay, so before we get all this off, let's just start with the basics. Voltage rails, no harm in doing this. Okay, so we have a nice convenient ground point here that goes to the mixer. I can get down onto the ground there. Yeah, that is definitely ground, so we'll measure from there. We will power this up with the mixer panel attached, because there's no point really measuring these voltages if it isn't. That is a load on these voltage rails. So I'm going to measure here for the HT voltage, and I'm going to measure on these op amps. I'm going to go to the pin 4, which would be the negative supply, pin 8 is positive. So I'm expecting probably plus or minus 15 here, and some high voltage there. Okay, so switch her on. And we have 82 volts. Okay, I like how it goes red for high voltage. Minus 82, 83. And then on these op amps, for 15.6 minus 8. Oh, do you know, maybe these are single op amps. Is it pin 7? Yeah, pin 7. So these are single op amps. Okay, this is getting a little bit warm, but they do, not hot. So we can say that the main voltage rails are there, and that ties in with the fact we have problem on one amplifier, so you would expect that to be the case. So what's wrong with our amplifier, and where should we look first? Well, the first thing I can see is this schematic is the wrong one for our amplifier, because this has plus and minus 52, plus and minus 104, we have plus and minus 84. This is a class G amplifier which switches the voltage rails. Okay, you can see all the output transistors here, and then we'll have, it looks like, yeah, here are the switching MOSFETs you see there and there. So rail A, this is the power to the collectors, plus and minus of all the transistors. And then we can see that we have a MOSFET that switches to the 104 volt, and we also have a diode which feeds in from here. This will be the 52 volt, I would imagine. So that is not our amplifier. Is there another schematic here? Yeah, this definitely isn't a Powermate 1000 PCB, because here's one. Yeah, I've repaired these things before. Okay, much bigger. This is the one with the dual supply voltages, hence the fact we have the 4 lots of capacitors, small one under my hand, look, big transformer in the middle here. So that is a Powermate 1000, which matches that schematic which I was looking at. Now, my first thought was that the metal cover that was on here has been taken off a Powermate 1000. It's the wrong cover. But if I look at the mixer panel, and it was on the video earlier, that also says Powermate 1000 on it, so that's also Powermate 1000. So it's possible that the mixer panels are basically the same, and this is a kind of Frankenstein, yeah, been put together from 2 mixers maybe. So I'm guessing possibly this number 84169H, which does not match that schematic. This could be a Powermate 600. Let me see if I can find a schematic for that. And it turns out this is not a Powermate 600 either, because this is one, and I've repaired one before. Ooh, 3 years or more ago, okay? So that is the Powermate 600. It looks a bit more like ours, but there's only one heatsink there, one fan over it that we can see here. So again, mine is something different. Let me see if I can find out what we actually have here. And it turns out, Googling for 84169H, I found this link to a PDF, okay? 84169H, Powermate 600. No, sorry, Powermate 1600. Okay. And I have a schematic for this one. Yeah, 84169H. Okay, we can see that, we can see that. And we can see with this one, yeah, we have the plus and minus 15 basically here. Look, regulators 78157 so that's there. Yeah, the 24 volt, remember I said there was another 12 or 24. It's also on this one, even though it's not what I thought. This is the red, blue, black high voltage output, and that would be this rail. Yes, plus 82, and this must be minus 82. So we've identified what we have. We have a Powermate 1600, but a Powermate 1000 mixer on it. So you can debate that down there, but at least I know what I have. And it seems to be a simpler design than the Powermate 1000. This is class AB, so a little bit less to it. So now we know what we have, let's figure out where we should be monitoring the signal to see where the distortion is coming in. And the problem is on this channel, okay? I mean, they look basically identical. We could start going around with the curve tracer, but I'm interested, we'll use the other method. So we'll get a scope and we'll have a look through to see if we can see where the distortion is introduced. Well, I think a good place to start would be here. So this is the left amplifier. We can see the audio comes in here through a couple of op amps into this one. Okay, into this little circuit by the looks of it. This is your mute, yeah, JFET there, mute signal. And then after this capacitor, it sort of goes into the amplifier. So I think if we go here, pin 7 of this one, I302B. Notice these are dual op amps, this one. But there must be some single op amp because I had the power on pin 7 somewhere. I hope I wasn't wrong about that. Oh, TL072, that's also a dual. Okay, well, we can always look again at that. But we know the NE5532 is a dual op amp and power where we'd expect them on 4 and 8. And then the standard layout really for a dual op amp, in on 3 and 2, out on 1, in on 5 and 6, out on 7. So I502, pin 7. And I302 pin 7. Well, I was just looking to see, and I've spotted what's wrong with this. Should have spotted it earlier, probably just wasn't as zoomed in as that. So this is what's wrong with it. We can see down here, okay. That may explain some strange voltage we saw. So what are these components? Well, that is 803 and 801. Can't quite read that. I probably didn't see this earlier because the wire was in the way, if you see what I mean. Yeah. Maybe it was obvious on the video recording. I'll find out when I edit this. But we have something wrong here for sure. Okay, well, there's no doubt this PCB has to come out, so let's get it out. So while just taking this apart, you have to get these out to get this out. It's just a pain in the butt. Now, I've noticed somebody's written on here. So this one says, looks like green or GN, but it could be in Spanish. Okay, that would be the black, which would be Nero or Negro, I guess. Negro. Hard to translate, but this one seems to be green, so that'll do for me for green. It could be gold. I mean, yellow would be Amarillo, and it isn't, so whatever. Okay, but that's another sign that somebody's worked on this previously. And I'm still a bit interested to know why I have a Powermate 1000 with a Powermate 1600 PCB in it. And this is our first glance under here. Okay, so fair amount of corrosion on there. Yeah, that's almost like something's got on there. It's like liquid. I mean, there's another one here. Why a few of them would actually have like this rust on and not on the others? Your guess. At least it's as good as mine, yeah. Okay, see if we get this PCB out. Okay, and now we can see this is in a similar state to a lot of things I seem to be asked to fix. Dust everywhere. Possibly some corrosion, but it mainly looks like dust. I thought this was the faulty channel because that's the one I had the speaker attached to that side, but maybe what's happened is these have been put on the other way around. Yeah, something like that. Although it doesn't look like it. Okay. And yet it looks like this is on this side of the amplifier. Okay, so let's see if we can figure out what we actually have now. So we have definitely here D803. And the one next to it I can't read because the markings look like they're underneath it. Yeah, that's an R resistor. Oh, resistor here, D. Yeah, it looks like D801 and D803. Okay, so we find where they are on the circuit. We should be able to work this out even if I can't read it. But that looks like D81 something and whatever. Okay, maybe 810, 809. Okay, let's have a look, see if we can find where these are in the circuit, and we should be able to work it out from that. Okay, I'm looking at this again, still trying to figure out what those are. It is symmetrical, but like mirrored. So we see here the red and black diode and this big one, 801, 803. And that's, I'd say, is 800 and 811. Okay. And then we have these further out, so there's a capacitor there, and I think that must have been a capacitor. And then this other diode, so that one is, I wish I could read this better, 803, 809. I may end up having to trace where these components go to like the fuse or these big resistors or something to get a better idea, okay? But I can see we're in this area, so this is the supply that generates the 15 volt. This is the plus and minus 28, it says here. And I can see D801, which is a 1M4148. It looks like one of them. Right colours, so 800 and 801 seem to be those two, which would make you think this might be 809 or 808. And 81 something, and there's 809 and there's 81 something. Okay, so these actually generate the 15 volt supply, which is, yeah, look, basically why there's a bridge rectifier, but we have a bad capacitor or a burnt up capacitor in this area from what I can see. That one, and maybe this diode's good, maybe it isn't. Let's just check them. Diode mode. So what's a diode? That also is like a diode. I think it would have to be because the voltage rail is there, yeah? Strange reading. Try the other way. Diode. Diode. So whatever that capacitor's doing, it's not stopping the diode from working. I'm almost wondering if this is even part of the problem, but I need to change it. Okay, well, cleaning it up a little bit, and we have some charred PCB. I think we can say that is C804. That's my best guess anyway. Which is this one on the output of the plus 15 volt regulator. That must have just burnt up, but obviously that's not what's causing this problem, because, well, the problem would be on both channels because the 15 volts goes to both. So we need to change that, and then we'll have to power this up on the bench now since I've got it out of this chassis, and see if we can figure out from here where the problem actually is. And in fact, I've found where the problem is. I decided, I was off camera, just thought I'd have a quick look around seeing this is on the bench anyway, and I decided just to check around these big transistors I could see, out of interest really, no other particular reason apart from the fact that I know that that is not the cause of the problem. Okay, so we're in diode mode, and if you look at these, that's a funny little triple bleep, yeah, that's a transistor junction, yeah, this is an NPN transistor, so positive to the collector should read open, in fact just a capacitor charging. Okay, this one, well, that's actually not, that's a PNP transistor. We can see the base collector, base emitter, so negative to the collector, capacitor charging. Okay, This one is another PNP transistor. Okay, negative to the collector, just the capacitor charging up. Okay, and this one will be an NPN, same as that one. Base collector, base emitter, and it's open circuit. Yeah. So base emitter's open circuit on this one, and that is Q517. We see Q317, and that 317 is good. 517 is bad. So we have an open circuit base emitter on the driver transistor, which means that these transistors are getting no drive, which is why it's horribly distorted. Now then, why is that blown? Well, it could be because there's a problem here, and because no fuses are blowing, it may be a problem here, and as I originally suggested, a problem somewhere in these resistors as well. So those resistors, well, here there's some more under that lot. Okay, these resistors are probably the emitter resistors. Yeah, the big chunky ones, they're quite thick. Yeah. Oh, in fact, the double resistors, look at that. Yeah, these are like dual resistors. But what about the output transistors on this thing? So these are all 5022. Okay, these are 5023. So the 5022s must be these must be NPN, because that was NPN, the one that's blown. So let's look at those. And there's 4 on each amplifier, okay, which is why we have 8 on the heatsink. So this is the side that's blown. That's the driver transistor just there. Yeah, these things are going to fall off now, of course. Probably these 4 transistors, just a guess really. We can compare with the other channel though. So that reads very low actually. That also reads very low. There'll be resistors in here, base emitter though. That looks okay. Another one here. This is the base. Well, again, it's going to read very low. So you're going to read to the collector from either because of the low value base emitter resistor. Okay. Are all these collectors all connected together? I don't see enough studs on the PCB. And yeah, schematic tells us all the collectors are connected together. Okay. So I'm wondering if the amplifier on one of the collectors. Well, as I say, they're going to read basically the same because the base emitter resistor. Okay, that's that half. I'll read the same all the way across because again, base to collector, all the collectors are connected together. And the same thing with these resistors. So it doesn't look like I have any faulty output transistors. It just looks like I have a faulty driver. That's interesting. What do these resistors look like? Ohms range, so they should read about 0.4. Yeah, 0.57, 0.3. Yeah, so this is suggesting to me all we have here is a faulty driver transistor. Okay, may as well just compare it with the other side. Close enough. Okay, what is this thing? And I bet I haven't got one. MJL3281A. I definitely don't have those. But what drives this? Well, it comes through a resistor, which is a good thing, and it comes through a couple more resistors here, there. We see them as well. 68 ohm, 68 ohm, 100 ohm, and it comes from this transistor. So MJE350, this is Q500. If we can find that, and this is the idle current setting and all this, Oh yeah, it comes from here actually as well, you see. There's another transistor in the circuit there, which that must adjust the voltage here. Like a bias, that's what you expect the idle thing to do. So if we look at Q527 and Q500 and they look okay, and we measure that pot and it looks okay, then it's probably the transistor, although it doesn't explain why it went. Well, here's Q500. Have to get it to it from the other side of the board. Yeah, it's that one. What's it look like? Well, it looks like a transistor with the base in the middle. We can compare that with the other side actually, which would be this one. Yeah, it looks the same. Okay. Yeah, looks exactly the same. Okay, so that's fine, I would say. And here is Q527, which should be an NPN transistor. Okay, we'll leave the meter where it is. See a base emitter, could be a resistor. We'll check the other one. There's a diode here. That reads okay. There'll be another one of those. Yeah, this one. How's this one look? It reads the same sort of thing. Okay, so I'm happy with that. And then lastly, does the pot read okay? Well, you know what, actually, I think I'll change these pots anyway. It's just good practice, yeah. So I won't even bother. I'll just get some of these pots as well and I'll change them because these can cause all sorts of problems, yeah. I mean, I can measure it, but even so. Well, that reads 0, so it's probably all the way over to one end. 174 ohms, yeah. And to the wiper from this end should be the same. Doesn't actually. Interesting, because the wiper reads to the other end. 175? Yeah, 175. So it reads the same to the wiper. So it's probably okay, but may as well change them, I think. Okay, so what do we do? Well, we charge the owner €65 for my time dismantling all this thing, okay, and finding the fault, and we tell him that if he leaves it with us, how much are these things? MJL3281A. Well, I can get a pack of these things, but they're like €57 plus another £5 of postage. Okay. I can get 5 just of that transistor. I'm tempted to go for the used ones. These are used. Yeah, these are used as well. And I can get a pair for €6. Okay. Plus another 2 almost in postage. So I'd order at least a couple of pairs. There's a fair bit of space around them so I can manage to solder the things in, even if the legs are short. Okay. I trust these more than I would with new ones, to be quite honest. So we're going to tell this guy another €20 for the parts as well, so 85. And I'm going to tell him he can have it back on Friday. And if he wants me to change the parts, it's going to cost him another 40 to take it all apart again and do the job. Whereas if he leaves it with me, I'll do it in one go and I won't charge another 40. What do you guys think? Yeah, what do you think? Because I think that's about right. Okay, hope you enjoyed that. Yeah, at least we got somewhere. I didn't think we'd actually fix this today, but interesting. The capacitor, well, that's not an issue, so I'm not worried about that 100 nanofarad capacitor. So I hope you enjoyed that. Quite interesting, actually. Interesting fault on this one. Of course, I'd love to know what you think. A, about the diagnosis, and B, about what I would charge and why. Yeah, talk about it down there, and I look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now, guys.